Okay, so for today, we were looking at why do relational databases still exist? So last time we talked about some differentiation between um, uh, our different kinds of databases that are out, and we talked about kind of the goals of relational databases and how they kind of came up during a time period where memory was very expensive. We didn't have a whole lot of it, so certainly with anything computing, we do need to store data. So they had this goal of, well, we need to store data, but let's try to store it in the most memory efficient way possible. That was the concept behind relational databases. Our modern day data stores, object-oriented databases, NoSQL databases, I think that kind of covers the newfangled types of databases without getting into database theory stuff, which is in a different class. Their goal is not necessarily, well, their goal is speed, right? And how they accomplish that speed might be in different ways, but one of those ways is through duplication of data by distributing the data across multiple compute resources and stuff like that. So what we were looking at today is, why do these relational databases, these older databases, why do they still exist? What do we come up with?
Well, one of the things is multiple things. One thing is because of its malleability or flexibility to expand better than the NoSQL object-oriented databases, in the sense of it's kind of cheaper to expand because it can use upgrades of system upgrades like RAM and storage instead of more uh, computing devices. So for object-oriented databases, I found that we expand vertically. So we increase servers or computers in order to expand our databases, while in relational databases we can
Okay, so the argument is that potentially relational databases are more flexible in terms of you can increase their abilities by just increasing storage.
or RAM or
Well,
memory.
yeah, whatever, on a single machine
Yeah.
is the idea. Well, can't you also do that same thing with a NoSQL database?
Yes, but that's why I mentioned that it's easier with relational databases and cheaper with relational databases.
Okay. But even with a NoSQL database, if we have, for example, a MongoDB server sitting on a computer, rather than distribute across multiple computers for faster access for lots and lots and lots of users, if we just wanted to be able to store more data, we can certainly expand the hard drive, expand the RAM, things like that, and gain a pretty much the same benefit as we would from a relational database in terms of storage size. Now, let me ask you this. Is a NoSQL database, let's assume you have a single computer, just one computer, not an army of computers. Is a NoSQL database superior to a relational database if you have it running on one computer?
Probably not.
Yeah, probably not. Maybe it's a little friendlier format for like a modern day developer who's always already used to using JSON. Um, Not that they haven't had a course in database and writing SQL stuff or whatever. But if anything, you might be able to argue that a relational database actually has higher performance on a single machine because of the nature of calculating, joining tables and things like that, rather than, hey, if I want to get data from multiple places, I have to kind of go and mine that data out of, these blobs of JSON objects that are floating around. Okay. So it seems like there is still plausible uses for relational databases. Anything else we came up with for why relational databases are still a thing?
Well, one other thing that is, I think it's so common with NoSQL databases is that it does not allow duplication because of the uniqueness of how it stores data.
What do you mean? So you're saying a NoSQL database
No,
doesn't,
I'm saying the
relational database is difficult to duplicate and resource intensive, probably to the point that having the data duplicated across multiple machines would be problematic. Does that mean we can't have something like an Oracle database supported by multiple computers with a single database?
That's not what I'm saying. I'm saying the data itself, the stored data itself, is not duplicated because of the way it's being stored, of the uniqueness of each column and row. You cannot have duplicated data within tables or tables within each other. It's difficult then.
Okay, so you're saying if you wanted to store multiple records with the same information in them, you can't pull that off in a relational database? Or are you talking about you can't make a copy of the data and put it into a copy of that relational database? The second one, okay. Well, so you could do that. The problem is keeping them all up to date, right? If it changes in one, now you got to make those changes in all the other ones, and now you have problems with like race conditions and stuff like that, where what if somebody was querying one of the databases, yada, yada, yada. All right. Okay, so let's say it's reasonable enough. Anything else? I think we're kind of missing the obvious one.
I think the most important thing is our relational database has 30 years of more time in development. So it's more popular in the community, or at least people are more familiar with it.
Sure.
And the second thing, and another thing relating that, as we talk about in a small scale, medium scale database, there's no real advantage of non-relational database over the relational database. Not like nowadays we have different programming languages. Your language definitely is more friendly than the older programming language. So there's no it's not completely superior. So why we use what we are not familiar with and less performance, and even less help from the development community?
Sure.
I would say the community is a big issue because a lot of they have so many resources of the old relational database rather than the non.
Yeah. So we could say that for most applications, we don't really gain that much from a NoSQL database. Not that there aren't some specific things where we would. For most applications, we don't really gain that much. So that's one thing, right? So kind of if it's not broken, don't fix it. That's one side. And then as Blade pointed out also, there is tons and tons and tons and tons of documentation and code examples and things like that out there for working with relational databases. Let's call it largely like MySQL and stuff, but it's kind of all the same thing if you're using SQL to communicate with it. Not that there isn't also a growing amount of code examples and things like that for NoSQL databases, specifically like MongoDB has become a fairly popular popular one, or things with Azure, their data store. But at the end of the day, if you're a developer and you need to get something up and running relatively quickly, you'd rather be pulling from a fairly mature set of online data than the maybe the dabblings of some of the NoSQL stuff. And we'll actually run into that. I think I mentioned it last time. When we start getting into code examples in here, there's going to be situations where we try to do X and it mostly works, but we're going to get a weird error, and then we're going to have to kind of go and tweak it some until we kind of get things working for the current version of MongoDB, or the Node.js isn't talking to MongoDB quite right because this version was just updated, which isn't compatible with the driver for this version and stuff like that. Where MySQL isn't. That's not a product that's changing a whole lot, like in terms of these drastic swings now, right? It's been around for a couple of minutes, and the languages that like easily plug into it. So I mean, if you had like a go-to move for web development dealing with MySQL, it would probably be PHP, right? PHP, MySQL, they're basically married, right? You know, PHP day one had built-in tools for talking to MySQL, as well as like PostgreSQL. It has basically built-in drivers for talking to these relational databases that have been around for a long time, and that solved the problem of the OCDB. I think it was OCDB drivers that you used to have to put on Windows and use Windows as your intermediary. But in any case, if you go and look at MySQL and PHP examples, you're going to find a lot, a lot of those, and they're going to be mature, they're going to work, and all that jazz. All right, so lots of developer documentation for relational database that is mature in nature, so we can rely on suggested fixes more often. All right. And I think some of the other things you said do make sense. You know, that kind of fits into this first category here is like, look, you know, maybe a NoSQL database makes some sense for kind of specific applications. Maybe even our more modern approach to writing applications might lend themselves to NoSQL databases. But when we look at this in terms of broad strokes of software development, you're not really getting a whole lot out of it. In fact, you're probably losing some, especially when we consider the documentation and the number of tools that already exist for communicating with relational databases. So I'm not sure that we can make the argument that relational databases will never go away. You know, they might eventually, their candle might burn out. But you know, frankly, at this point, we don't care about them being more memory efficient. That ship has sailed. We're not worried about that anymore. Although it is kind of interesting, you know, we have this perception that, you know, memory and whether it's system RAM or hard drive space is super cheap now and things like that. Like if you were to go out and buy a new laptop today, it almost feels like the new default amount of RAM is 16 gigs of RAM now, right? Like you almost have to try to buy a machine with only 8 gigs of RAM. Isn't that a true statement?
No, there are still, but not that many.
Unless you are buying Apple device.
Well, no, but here's the reason I bring this up. This was a last night situation. My wife's a COBOL programmer for Western Illinois University, where I used to teach. So she's been there for 21 years. But when I left there in 06, she became their first remote employee. So she's had her office at her house for a while, right? And so originally she came up with her desktop computer, and I don't know, sometime in there, they upgraded her computer once, so they sent a new computer. Well, now they're moving to laptops. So they sent her the brand new laptop yesterday. It only has 8 gigs of RAM in it. It just didn't make sense to me. Like, you know, how much more? I mean, I'm sure that it's a Dell Latitude, something or other, and I'm sure they have some contract, you know, the university with Dell, right? Through their IT, they're buying hundreds and hundreds of, I mean, how much of a cost difference would it have been to get that thing with 16 gigs of RAM? 50, not even. They're buying those things in bulk. 15 bucks, maybe 20 bucks. They might have even just thrown it in. It's like, oh, you buy another 30 of these. Yeah, I'll give it to you. it's fine. You know, so I'm going to end up upgrading her RAM, but the problem is I'm going to have to open it up and find out, is her 8 gigabytes, is it one chip with an open bank, or is it 2 4 gigabyte chips that I then need to pull both out to put a, we'll see. It's not a deal breaker type thing. It just kind of surprised me that, you know, a brand new laptop, and she had to break the seal on the, on the thing. Only she, you know, for a professional developer, only came with 8 gigabytes of RAM. I mean, she does do her development remotely on a mainframe for COBOL development, so she's not using her local system resources tons. I don't know, it just still surprised me. I don't think I'd buy a laptop with less than 32 gigs of RAM.
Nowadays, no, I think still 16 is relevant.
No, it's relevant. I'm saying personally.
Oh, yeah.
I wouldn't buy a laptop with less than 32. Yeah, I mean, it doesn't make sense. Well, I run all these different OSs.
Yeah, with that,
Yeah, so I use those system resources commonly. If I had 8 gigs of RAM, I wouldn't be able to function. It's terrible.
That's why they use all the disk drive, you always need extra.
That's true. In fact, I specifically changed my tea time for tomorrow so we can go to fish.
And there's another benefit, I think, about the relational database is
Sure.
because of the performance specifically. Uh, if we're thinking about, for instance, as you mentioned, if you are doing a query, relational database, you have the way to optimize by changing the way of the SQL you load.
Sure.
But for non-relational database, usually they lack in the way, or you even have to write SQL in order to optimize.
Or write your own JSON parser for pulling the stuff out or whatever.
It's usually very inconvenient.
Sure.
Optimizing. For instance, one of the common issues is about when on a page you are doing pagination. For SQL, you can optimize first, say for adding index, trying to making the sorting quicker. But for non-relational database, usually they lack the way. You have to pull out everything.
Right.
You only put out the first step.
Yeah, so kind of this thing here. So SQL is a really mature tool, been around for a while. Its relationship with relational databases has been set in stone. So the developer, not that they always need to have high performance queries, right? You know, usually whatever, you know, your crappy just go-to move query is going to be good enough. But if you were in a situation where you needed to really focus on the speed of it, you have the ability through SQL to write more efficient queries and things like that. So whether, you know, at some point you can say, well, is that better than NoSQL? Or it's probably fair to say right now that it's not significantly worse. If it's worse at all, it might still be even better. So again, it's not a rationale for getting rid of relational databases. Okay, so I think that covers that pretty well. So let's see, let me just back up a couple of slides here. We were talking about, so the model view controller somewhere in here, right? So model view controller, we talked about separating the data, which probably lives in your database. Keep that in one place, your user interface and your controller, your actual logic in multiple different places. When we have this concept of a full stack developer, so you're hired as somebody who has a skill across those various verticals, probably within kind of a single ecosystem. We're going to be looking at something in here called the mean stack. But you know, there's the LAMP stack, which is a PHP based thing. There's a bunch of stacks that are just kind of these 3 products or these 6 products work very well together. So we're going to give it a funky name for the stack. Maybe it's related to the product names or whatever, but you know, whatever it is, it's you know, these are the you know, the kind of the go-to move. But anyway you cut it, that's, you know, no matter what the database is, you're still working with a database. No matter what the language is, you're still working with a programming language. So if you're going from one stack to another, not the end of the world, you just get familiar with those tools. But the idea of a full stack developer says that you're comfortable with interface design, the controller for the thing, and also interfacing with the databases. So we talked about some different front-end technologies, back-end technologies, database technologies. So if we're talking about some of these front-end, the what's under the hood with our front-end technologies, I want to draw a picture here.
But how often does full stack developers work on databases?
How do they work on databases? Is that what you're asking?
How often? I mean,
oh, how often? Oh,
yeah.
well, I mean, I think very commonly, because I mean, I would say that, you know, many websites today are going to interface with a database. So, you know, full stack developers are probably going to commonly work with the database. Now, with that in mind, and maybe this is what you're asking, how often are they really going to get into the weeds working with a database? You know, I wouldn't say that a full stack developer is necessarily going to be expected to have the skill set of like a professional DBA. But they'll know enough to get by where they can create tables and query from tables and join tables and do inserting rows, removing rows, things like that. So I think pretty commonly they'll be writing code that will be manipulating a database, as opposed to they wouldn't necessarily be working with the database, like installing the database or getting doing backups on the database, things like that. That's probably going to be somebody else's responsibility. But to your point, that actually was kind of a big problem from, let's call it the early days of full stack development. If you were, and that's kind of what I'm going to show here in this next slide. I want to draw a picture of kind of what does the internet ecosystem kind of look like. So we have from a networking perspective, we're really looking at a client-server model, right? So we have our client, we have our server. So this is a generic networking model. Okay, now, generically speaking, what is a client and what is a server? What's the role of a server generically? We're not necessarily talking about a web server, just a server. Why is it called a server? Okay, so it gives a service, it serves stuff, right? Probably data in one way or another, especially from our perspective. And here we're talking about APIs. So we're probably going to be talking about something that you request crap, it sends you crap. All right. Every now and then you might want to be putting some stuff in, but generally it's going to be serving you data. But I think what you said makes a lot of sense. It's providing some sort of service, which might be the idea of serving data. All right. So we have a client server model. Now, what's the client? Yep. So if you go into a restaurant, you sit down, the server comes up to the table, asks you for your order. You place your order, they bring it out, right? And you can have multiple clients working with the same server at that table, right? Okay, kind of that same kind of model here. Now, when we're dealing with this in the web world, what is the client in the web world? Okay, well, actually, let's deal with the server side first. That'll be easier. What's the server on a in a web system? Okay, well, okay. So when we say the word server, we're really talking about two different things, right? We can be talking about a physical computer. This can be a physical computer, or it could also be a piece of software running on a computer. Because you can have a single physical computer with multiple pieces of server software running on it, right? You could have a single computer that's running an email server and a web server and early days of the internet, a Gopher server, a FTP server. Yeah, Gopher was like Google before there was Google. Way back. This is day one of the internet type thing. All right. So when we say the word server, it can imply a couple of different things, right? Okay. A physical computer, I would say, is typically where the server software lives. Okay, so ultimately, from a programmer's perspective, when we're talking about the server, we are talking about talking to a piece of software. Where that software lives is kind of unimportant from the programmer's perspective. The faster place it lives or the more duplicated it is, whatever it is, the more performance we're going to get out of it. But from a programmer's perspective, we're probably going to be talking to it in the same way as we talk to anything else. So generally speaking, we're talking about a piece of server software that's running on a computer. So typically, when you have a piece of server software, let me create another slide here. Anybody know the kind of the generic OS term for a piece of server software that's running on a computer? I'm kind of talking about processes that run in the background. They don't necessarily have a front-end user interface or something like that. What's this kind of program called? Computer program that runs on a operating system but doesn't have a user interface. So it's just running in the background. Service would probably be a generic, more modern term. Not what I'm fishing for. Starts with a D. A. E. Daemon.
Okay, this term is always confused with
Yeah, so daemon is a process that runs in the background with either no user interface or a limited on-demand user interface. All right, so for example, if you're running MySQL, a database on a machine, okay, MySQL itself doesn't have a user interface. It's the MySQL daemon, right? You can call up a user interface, a way to kind of, you know, at the command line, work with the database so you can, you know, test the query out, things like that. But the default database itself runs in the background. And a lot of times you'll, if you're like on a Linux box or something like that, so we can say, for example, MySQL D is the name of the executable for MySQL, where the D here stands for daemon. This is the MySQL daemon. So these are kind of naming convention things that you might bump into in the future. All right, so back to this guy here. When we're talking about servers, we're probably talking about a piece of software running on a computer. So let's see, I've got to be able to do something awesome with that, right? Boom. All right, that's probably the guy we're talking about, right? All right, but they're all ultimately running on some hardware, but from a programmer's perspective, we probably don't care about the hardware something's running on. We just expect that it'll be fast enough to do what, to handle the number of simultaneous users or whatever that it needs to handle. All right, so if we are dealing with the server and we're talking about a web development ecosystem, I had an echo this morning. Spelled that a little weird. It's okay. I don't know why they call it an echo. The thing I had this morning, it's a echocardiogram. Because it bounces in and bounces back.
Then the cable, the light cable.
Yeah, but isn't that called sonar? Or if I'm a submarine and I'm doing that out, they don't call it an echo. Actually, they might call it an echo. I think they do call it an echo. My full knowledge is in the movies, and I think when they use sonar and it gives you a result, I think they call the result they got an echo. Oh, we just solved that problem. All right. So if we're talking about in the web development ecosystem, what's an example? What kind of software is going to be the server in our web development ecosystem? We actually probably have two servers running here, right? We're probably going to have some kind of web server running. And then by our same standards, we're probably also going to have some sort of database server Okay, they may or may not be running on the same machine, right? But these are two pieces of software that are running somewhere that we might need to interface with. So for right now, just for this picture, I'm going to throw our database server kind of up here in the cloud, you know, implying that it's probably not sitting on this machine because we might want to have access to it from multiple places. But again, where it's living isn't important. It's a piece of software that's running somewhere that we have access to. All right, so we have our server, specifically a web server. Do you have examples of some web servers? Apache? I meant web servers that matter.
All right. It's starting to get to,
Well, if we're limiting our things, what's Microsoft's web server called? Yeah, IIS, Internet Information Server. All right, so these are actually, you know, two common products that you might be dealing with in the world today. Apache, any Unix system that's running is probably running Apache as their web server. IIS, if it's a Windows-based server, you're running a, you know, Internet Information Server. Yeah, there's some other ones out there, but these, let's call these guys the old stalwarts. The percentage of installs for your web servers in the world, this plus this is going to get you well into the 90 percentile, you know, comfortably into the 90 percentile. All right. So those are some examples of web server software that's running on a physical computer that lives somewhere out here. This guy over here, by our definition, this is the back end or server side. All right, so kind of giving some words to these things. All right, now go over here on the client. So what is a web client? Probably is a browser, right? Okay, so this guy is going to be our web browser. Andrew. Oh, this is going to change the font. All right, that's our web browser. What are some examples of web browsers? So Chrome, Safari, and Edge. I don't think.
or it still exists.
Why do you make a Firefox?
Well, who would use Firefox when you have Chrome?
But someone still use it. Like it's still more popular than
Probably used to use.
You still use Firefox?
I only use Firefox
I still
because
use.
some computer only.
I choose Firefox better than Chrome because of add-ons we have in Firefox.
Okay, so you like Firefox over Chrome because of the Firefox add-ons?
Yeah.
Chrome's add-on, that ecosystem for Chrome's add-ons isn't big enough for you?
I think Chrome, it sucks more RAM than Firefox, so I just
Okay,
prefer
all right. So you want me to put Firefox on this list is what you're saying?
I have a fair solution. You can replace Edge with Firefox because Edge is technically the new Edge is Chrome.
Oh, okay. But it's also pre-installed on Windows machines. You're gonna have a lot of people who just magically will click the, well, it's not the blue E anymore, but all right, here. I'll keep Firefox on the list if you can tell me what the previous web browser that Firefox was born out of. The Firefox project was born out of a much older web browser. What was the name of that web browser?
Sci-Fi.
Who?
Sci-Fi. No, CP, sorry. CP.
CP. No, not that I'm aware of.
Netscape.
Netscape. So there was an older web browser called Netscape that was closed source, and then Firefox was the open source version of Netscape that then became fairly popular. This is years ago. This is in the early 2000s. No, yeah, early 2000s. What browser came before Netscape? What was our first graphic user interface browser? It was developed at NCSA, National Center for Supercomputing Applications, in Urbana, Champaign, Urbana, Illinois. It's called Mosaic. Mosaic web browser. Yeah, so if I go Mosaic web browser. So this was out of NCSA. It was one of the first web browsers. See, look at this cool. It had a little world in it with the two deals on either side. Let's see, does it give us a year? Final release was 1997. Initial release was 1993. All right, now, if it was initial release was in 1993, it was probably in beta in like 1991, 92, something like that, right? Okay, there was this kid named Mike Littman who lived in Rantoul, Illinois, about 10 minutes north of Champaign, Illinois, whose mom would drop him off at the computer lab at NCSA because that's where the internet was. They didn't have it coming to the house then, right? And so I was this young kid in there with the people who were writing Mosaic were letting me use the beta way before it came out. Because prior to that, you would have only been able to use command line browsers like Lynx, LYNX. LYNX was one of the popular early ones. Okay, so I'm part of this history. So NCSA, National Center for Supercomputing Applications, is on Green Street in Urbana, Champaign, Urbana, Illinois.
So the beta version, what the OS it is
Oh, this would have been running on Unix.
on? Okay.
I want to say I was using it on an IRIX machine from Silicon Graphics. Okay, so we had a computer called, so this was IRIX OS on Silicon Graphics. Let's see if I can actually point out the machine. Oh man, look at this. That is some awesome stuff. But I didn't have a GUI when I was originally using it. The running MIPS processors, 175 megahertz. That was actually much newer. That's way after it had been out for a while. Just want to see if I can get a picture of the computer itself. Founded in 1981, defunct in 2009, Chapter 11 bankruptcy. Oh, those were the days. Yeah. But it is kind of interesting that I was part of the internet history. University of Illinois in Urbana-Champaign was one of the original universities that were part of the internet, because the internet was born out of collaboration of computers, of local area networks that were attached to each other through a larger wide-scale, wide area network. And the language that they used was mostly for like research stuff, quickly sending stuff back and forth that email wouldn't really support or something like that. And the language that they developed for sending that information was called HTML, for wrapping that information. So kind of an interesting part of history. just say web. Urbana, Illinois. Let's see if they show a picture of the building, because the building itself is now a computer. It was one of the early supercomputers. Yeah, right here. So this back part is actually a big computer. You have the assembly hall where University of Illinois plays basketball, just to that side of that guy. You have their football stadium right across from this. Brings back some memories. All right, so we have some of our web browsers. So these would represent the clients of our web servers, right? So these guys, and you might have multiples of these. So maybe, you know, I'm using Chrome, Blade's using Firefox, probably too many of you are using Edge, are connected over to one of these web servers, and these guys are communicating with each other, right? So we have communication that's occurring between our web server and our web client. All right, and over this communication, so this is like a telephone call, right? We're opening up a line of communication, a socket connection that goes between these two, and they're going to be speaking a language, okay? In computers, when we talk about a language, we're talking about protocols, right? A protocol, AKA language. All right, so right now I'm speaking the English protocol. All right, some of you speak Telugu protocol. We have Arabic protocol. You speak Chinese, not Mandarin, right? What's the name of the specific language you speak?
Mandarin.
Oh, you do speak Mandarin, but Mandarin is the Chinese language.
Yeah.
What's the alternative? There's a second language in China, isn't there? Who? Cantonese, that's it. Yeah, I just know it by their food. Because there's Mandarin style cooking and there's Cantonese style cooking.
Well, I would
Both
say
are good.
Cantonese is one of the food. Yeah, they do have their own, but it is only like a small portion of the whole food.
Well, which one's spicy? Is that the Cantonese one?
No, which one?
So Szechuan, yeah. Well, now I'm hungry. Oh, so good. All right. Okay, so in any case, you know, we all as human beings, when we're speaking to other human beings, we're using some sort of language, we're using a protocol that we agree upon. What's the protocol that our web client and web server have agreed to speak? Yep, so it's HTTP. And actually, if you were looking at the Apache the processes that are running under Apache, you'll find one called what? HTTPD. What does the D stand for? Amen. Look at that. Yep. All right. So these guys are speaking the HTTP protocol. This is the Hypertext Transport Protocol. There might be a space between the hyper and the T. I'm not sure, but something along those lines. All right, so this is the Hypertext Transport Protocol. And what is hypertext? Yep. This isn't just necessarily plain text. It's something super or hyper. It's a hyper version of data. So we can send all sorts of different stuff across here. And we typically, one of the main mechanisms we send stuff across here is through HTML, right? So we make requests using HTTP from the web client to the web server. Usually these requests, they come in 4 formats, right? There's 4 different kinds. So if we throw a thing here for HTTP, what are the 4 functions that HTTP supports?
Yeah. Post, push,
One more character.
put,
Put,
yeah, and
delete. So these are the 4 functions that are supported by HTTP. Now, for a long time, we only used 2 of those functions. What are the 2 functions that were popularly used? Get and post. So get, actually, I'm gonna leave it like this for right now. All right, so these are the 4 functions that HTTP supports. We're gonna say common with well, let's call it common with web servers. Oops, not being close. And this guy is also common with web servers. So when we talk about get, what is a get used for when it deals with web servers? If we are a web client, if we are one of these guys and we are sending a get HTTP request to a web server, what are we asking for? Yeah, we're requesting a resource. Maybe it's a .html file, maybe it's an image, whatever it is, something, right? All right, so this guy is a request to the server for some resource. All right. What about a post?
something from my side.
Okay, so post something from your side so this is a send data from the client to the server. All right. When is this common in web stuff? When would we see posts most commonly in web stuff? Yeah, web forms. All right. Can gets be used for web forms?
Yes.
All right. So we'll create another slide here. What is the difference between get and post when using them with web forms?
Put the content in the URL.
Yep. Okay, so a get puts all the variables read in from the form into the URL. So the URL is a uniform resource locator, which is just the text up in that little bar at the top. Okay, so this guy up here, this is our URL. All right. Actually, here's a good example. This guy's doing a GET request, right? So we have www.google.com/search, and we have this little question mark here. And we have a variable called Q. Q is equal to national plus center plus 4 plus supercomputing, yada, yada, yada. Then we have an and, then we have another name value pair, and then there's probably another and down there somewhere. Okay, so what we're doing is we're taking all those variables that we're passing along, and we're just putting it all up in the URL and creating a big giant string. Okay. Whereas a post, so here I'm going to put, this ultimately creates a plain text string that is visible to the end user. A post puts all the variables right in from the form into the header for the request, for the HTTP request. This is not necessarily encrypted, so probably plain text, but not readily readable without effort. Something like that. All right, so it's not that a post is more secure in and of itself. Both of these, a get and a post, typically, if you have like username and password, a get's gonna have your password in plain text right there in the URL, where a post will have your password in plain text as part of the header, but if somebody's doing some packet sniffing or something like that, they're going to see your password. it's right there in all of its glory. Same thing with credit cards and stuff like that. That's why when you're, putting your credit card information in someplace, you like to look for that little padlock, right? Padlock on the web browser, which means that it's being data is being encrypted. You're probably using something called SSL, secure socket layer. All right, which is using some form of SHA-256 encryption usually. That would be a 525 class stuff. Okay. So this is the communication protocol that we're going back and forth between these guys. Here's our, go ahead.
I think the hypertext don't have the space. If you load it. No, that. You can.
Yeah, he thinks it's hypertext like that. All right, so we've introduced this. So now I want to give you your next homework assignment, because I have a meeting here right at 9. So homework. I'm going to need 2 pages. Write a 2-page paper describing what a RESTful API is and how it relates to HTTP. I think so, because you need to tell me about RESTful APIs. Here, let's make you feel better. Let's say 1 to 2 page. I don't care how long it is. As long as you explain to me what a RESTful API is and what its relationship with HTTP is, and be ready to talk about it next class. You with me? All right. Questions, comments, concerns, bribes? All right, I will see everybody on Tuesday.